A couple of the issues we have to deal with as we're looking at nuclear power, new nuclear power, is we have to build. And assuming a lot of other things are all taken care of, personnel challenges and challenges of bringing in the workforce we're going to need, and how are we going to teach them the knowledge that's going out the door, because we've all seen the statistics. 30% of the workforce is going to slated to retire in the next 5 years. And if we're going to double, triple, 10,000, 20,000 new workers, how are we going to bridge that gap? It's using technology will be a piece of that for us. And one of the other things we have to look at is, I talk a lot to our customers, which some are here today. What is it they want? And some of the things they want in their IT systems is they want a flexible view. They want to be able to see all of their information at a touch. They want to have reliable systems that grow as their business needs grow. And they also want to have, when you're getting an update to your software, it's done right, it's done smooth, quickly, and with minimal cost. And these are just some of those challenges that their wants, their needs, and they obviously want mobility, they want AI, but they don't know, they know they need AI, but they don't fully trust it. So how do we bring in those AI, ML solutions in the right places that help into the system? I'm really sorry that we can't get the technology figured out here. And so what does that really look like for us is how we're going to bring that into you. And then we apply those personnel challenges in the training environment. How are we going to help them actually use those mobility solutions when they're first getting trained? How are we going to actually use the software systems that they're going to use in the plant? And that's a very big piece of it. And then from all of that, you have to back it up and go, well, how am I going to get all this? Well, it starts at the very, very beginning at design. And part of what Xavier and I are going to be talking about today, if we can ever get it up, is how we build your plant from that computer design to where it becomes an actual physical plant that comes into operation. And how are we making out?
Yeah, so just maybe to complement.
Yeah.
So when you are an organization launching a new nuclear build program, in fact, it's a long journey from the site selection, the vendor selections, and setting up the project and the program, doing the surveillance of the design and the delivery, and going to the operation. And we believe in Hitachi and Dassault Systèmes that it's also a digital journey. So you cannot go in this kind of endeavor without also planning the digital capabilities that will support the business capabilities. And that this digital journey has to be started at the initial stage, when you are still in the feasibility studies, you are still selecting the site and the technology. It's the time to start planning your digital journey as long as you do your business and feasibility studies. So.
Yeah, so as Xavier was saying here, so we talked about some of these, the world challenges, new builds, the digital trends, and really what that thing called a reference plant looks like, what it means and why you want it. And then you bring all this together in your PLM and your EAMs as you actually integrate them into a usable solution. So part of our shared ambition here with us is we want to help bring the industry to these realities smoothly and quickly. And I'm going to go through some of these just quickly so we can get them, we've talked about it. So we all have seen the slides like this, they say we need 200 gigawatts of net new nuclear. That was 3 years ago, prior to the explosion of data centers. The reality is while we have about 200 being built, a little over, it's closer to 900 gigawatts of net new nuclear is going to need that they anticipate to meet what that means. So what we're doing here today is double what it was 2 years ago, and it's only going to be bigger. And that's really the message, and that really brings our challenges to the forefront. And so when we talk about those trends, and I talked about some of this, I won't spend a lot of time here, but we've seen all these things. These are what our executives want, whether they're our generation executives, our IT executives, They want those improved quality software, easy to use modern interfaces such that they don't want people hunting pecking, right? The new workers that are coming into the industry need the information presented to them quickly so that they can consume it and use it. And that's really the challenge we have to help you solve. And as we talked about, analytics, you've heard about these things, the prognostics and modeling, and then actually what does a 3D digital twin really mean? Because we all say they want one, and there's probably 30 of them around here. They all are a little different. How do you actually use that in a beneficial way within your facility? And then again, as you're in and you're actually planning work, you're scheduling your work, you're doing this with less people now, junior people, and how does that actually come to fruition? And the big piece here is we have a lot of human performance tools that you have to use that we expect to be used. How can we use technology to enforce those human error reduction tools versus having people doing it? So we talked about this, and we're going to really get into the meat of it here since we've been delayed. I really want to get here, but I'll point this out. As we're building the new plants, we call it almost the cookie cutter approach. We build that reference unit that has the entire plant living digitally. And it has all of the work orders, all of those PMs that you need, and you cookie cutter, boom, 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 to the next plant, right? As changes are made, the concept of this modularity is that we're going to reflect those design changes in all of the units that are built. So there has to be a feedback loop there that's tracked and maintains a fleet management concept. And then you're also looking at how are these assets performing, even up through construction. And what does this do? This is where you have to tie everything together from the earliest design phase, that those first orders are going out long before you've ever hit a shovel in the ground somewhere, and tying your design that's going from the as designed to the as manufactured, as delivered, as built. Does it all line up, and do you have that, what we call the golden thread for your QA, so that at the end of the day, the owner-operator is given a licensing package that they have to go to the regulator. That has to be done quickly and smoothly. And that's what we call maintaining the golden thread. So I'll just go through these, but you can see as we talk about this, this is what we're looking at through these many things. All the drawings, the renderings, you're getting it from CAD. You're bringing it through. You now get spec sheets that go out to manufacturers. You get the finite analysis, those 3D models. Now they're coming back. You have to have certificates of these testings and quality. All of this is required as your QA trail. And then you're building your P&ID diagrams that are actually interactive. And then you're actually getting them installed now. What does it actually look like installed? Does it match what the physical site is now matching what you had designed? Where's it at? And you got your maintenance procedures. So all of this comes together into a complete package of that golden thread of life cycle. And it has to meet all your industry data standards, okay? And we do that through, and this is where we come into with our partnership with the Dassault Systems, is how we're going to help you as the customers take that from that computer over here to that real life plant. So Xavier?
Yeah, so as I mentioned, launching a new nuclear program is a long endeavor, it's a journey, and it has to be aligned with a digital journey that will support and provide the digital capabilities to supporting the business capabilities. And in fact, the ultimate goal is to be ready to start the operation with an operational information management system that contains all the data, models, and documents needed to operate the plant, to maintain the configuration, and maintain the plant itself. Can you?
Yep.
Maybe you.
Yeah, you want to do it. And and as he's talking here, to give folks an idea, at like Hinkley Point C, where we are doing this, they've had 2,000 plus design changes during the build already. Those all have to be captured, tracked, and be correct.
So the question is, how can you set up the operational information system for your future nuclear plant knowing that it cannot be the same as the one you have in existing plants in operation. It has to be a modern one. And so if we take a step back and we look at all the actors that are involved in the delivery of a nuclear plant project, you have the vendor, you have the EPC alliance, and the owner operator. Each of these actors have their own information management system. So if you look at the vendor, it's most likely a system which is designed for product. The objective is to deliver products. So small modular reactors as a product, whereas the EPC alliance will be focusing on project management, how to deliver the project on time, on budget, on schedule. And the owner operator has a completely different objective. The objective is really to maintain the plant on the long term and operate the plant on the long term. So the information management system of a vendor or the EPC, none of these are applicable for the operation. So it means that the owner operator has to take the responsibility of this system and take the lead on it. Based on our experience, there are some typical things and challenges that prevent the correct setup of this system. One of these things is the late setup. So the work to set up the system and to prepare the data is engaged too late in the project. And we think it has to be done early when you are still selecting the vendor and starting the project. Then there is often too much delegation from the operator to the delivery organization, meaning that the operator relies on the vendor to deliver the system, but in fact, the vendor himself will probably ask a system integrator, and at the end, the owner operator will be in charge of it. Also, it's often too much document-driven, so it means that the data and the models that you need to leverage AI, to leverage predictive maintenance and nice capabilities is not taken into account in the planning. And at the end, you end up with inconsistent and incomplete information. The answer to that is really to combine the strengths of the 3D Experience platform and the enterprise asset management platform from Hitachi and Dassault Systèmes to set up these systems and plan for these systems early during the project so that when the project is executing, you can start loading those environments with system breakdown structure, with component information, maintenance information, and prepare your maintenance plan and be ready for the operation. And we do think that you have to go for an early setup. So it means that you will go for a modular and step-by-step approach to deploy and set up the information management system. It should not be a big bang that you do at the end of a delivery phase, but really something you plan for, module by module, step by step, in order to secure it. And you can start, for example, by the design basis requirements, the product structure with the safety classification of all the structure, components, and systems. Then move to the development of a standard library of components, and I will come back on that. And progressively start building your maintenance plan, and be ready for the operation. What you want to have is a real copy of the engineering data from the vendor in your own environment, structured in a way that will allow you to maintain this information on the long term. And if we take the maybe the example of the of a supplier catalog, which I think is a good example, because at the end you will need for each material that you maintain, each type of material that you maintain, a referential coming from the supplier with all the information needed to maintain and operate safely the material. And in the past, it was mostly document-based. In the future, we all know that we have to go for a more data-centric and model-based way of doing things. So we don't want documents, for example, to have the FMEAs and the fault trees. We want models to be able to run these models into safety assessment. We don't want documents to initiate the maintenance procedure. We want ready-to-use maintenance procedure that can be launched in an electronic work package and that can be ingested in the EIM to plan the maintenance activities. And our value proposal is really to start early, build this supplier catalog management, this supplier catalog early in the project, leveraging standards which exist in the industry for fault trees, FMEAs, and so on, and then start connecting and pushing the information to the AM in order to be ready when the first material arrives on site.
We might have time for the video. Maybe show a little bit of it, yeah.
I'm trying to launch the video.
Nope. I don't think, all right.
Okay, so I'm not sure if you... Excuse me, is it possible to...
Okay. There we go.
Sorry about that. So what you see here is the, let's say, the list of suppliers for a given nuclear project, and for each supplier, all the materials that they can provide. So of course, you need to manage not only all the data sheet from the materials. So you want to have access to the data sheet in a numerical format so that you can perform searches and activities like that. But you also want to have models associated to these materials. Like for example, here we show fault tree analysis in a model-based way, so that this can be transmitted to your simulation tools for safety. There are no standard formats to exchange this kind of information within the industry. So it's important to leverage this format. Same for failure mode and effect analysis, or for maintenance procedure that can be also digitized and maintained as digital asset to be consumed by your operational system. So I know that we have a few minutes left. So here what we show here is also the capability to have dynamic models of your equipment in order to feed predictive maintenance system. If you want to deploy predictive maintenance, you may not have all the historical data to do it, but thanks to multi-physics simulation, you are able to generate scenarios and data to feed your AI in order to support predictive maintenance. So this is, you got the idea. It's go for model-based, prepare your data early, put in place the processes to review the information and ensure the quality and the completeness of information. Maybe I can leave you the end for the conclusion.
Nope, go back. That was it, yeah. And
you want to go?
Yeah, so I think, and this is where we come back to. So all of this, what it really means for you at the end of the day as the customer is that you're getting your information and it's being delivered so that it meets your IMPO standard model, your AP 928, your 929s, your 912s. All of those things are being met, and you can now demonstrate that with your regulator. That's the key piece here. And it keeps the work management area over there as your big driver once as you're building the plant. And these models are staying tied together all the way through the life of the plant, all the way to ultimately decommissioning of that plant. And that's the key piece here, is that we're going to run into challenges. We're helping the industry de-risk by taking away as many of those we can in the design, the engineering change, and that tight design control with your EPC and your manufacturers, so your plant delivery can actually achieve on that schedule. And I think that's really our message we want to end with here. So, and thank you, folks. And Xavier?
No, it's okay. Thank you for joining us. So we are happy to answer your question if you have. We can meet in the route in the next room, and you can still come to our booth till the end of the day. We will be there to support you and answer your question. Thank you very much.
Thank you.